Hi, ladies and gentlemen, boys and girls, wherever you are. I'm back with my lessons. Without wasting time, let's just connect ourselves with what we have been doing. Currently, to be reminded, we are working on trigonometry. Right, so we started looking at it in the previous video. I think you can go by the link down here, try to revisit what we did. For those who are joining us, I think you are also encouraged to do the same. Right, today we would like to take a different section of the trigonometry as a topic. And here we are, as per what is indicated on the board, we are to work on the trigonometric ratios of special angles. Right, so what is here is just like there are some problems in mathematics which always they may ask you to work on them, but you'll be required not to use a calculator. Right, so when such instances come, you'll be able to realize that in this case, you'll be given some problems which are dealing up with some angles which we call them as special, and there you are encouraged not to use the calculator such. And these angles, you mention them, are angles of 0 degrees, you talk of 30 degrees, talk of 60 degrees, talk of 45 degrees, you talk of 90 degrees. These are the special angles we are talking about. And as such, you'll be able to realize these ones have got their own special trigonometric ratios. So you are supposed to master the trigonometric ratios for 0, 30, 60, 45, 90. Every time the question comes, you should be in the position to drive them out, so that when you solve the problems, you don't have to use the calculator, you have to use the values as such. So which means in this case, we are there going to fill a table, which is represented here in the chart, right after we have derived such ratios. So the table that we have here is this one here. Look at this. Right, the ratios remain the same. Talk of the sine, cos, tan, like that. So what we will be doing is this, that once we have derived these ratios, we are going to fill the table like this. Look at this. So I'll give you direction of what we're going to do. Look at this. We need to find the sine of 0 degrees, sine of 30, sine of 45, sine of 60, sine of 90. Then we're also going to find out the cosine of 0. It goes like that. And the tan of 0, 30, 45, 60, and 90. So we're going to fill all these spaces what are there. So it means you're going to master everything that will be in here. If you're not talking of memorizing, because memorization is somehow not all that worth in mathematics. So you have to know how you can come up with the sine of all these angles, cosine of all these angles, tan of all these angles. So we'll be doing some activities here, take note of them, and at the end, we are there going to fill in this table. So let me remove this table first. Once we have done the activity and we've found the values of any one of those angles, then I'll be pasting this chart on the table and we're going to fill them with a pencil marker. Right, so here we are. We'll be going bit by bit. We cannot do all of them at the same time because they are different in terms of the way we can do in order to find their values. So as such, this moment, we are going to first of all begin with the 30 degrees and 60 degrees. What are the sine, cosine, and tangent of 30 and the 60 degrees? Right, a situation where will help you to work out problems without using a calculator. Right, so allow me first of all to remove this title in order to create more space, right, for discussion here. Right, so let's have the special angles. First of all, you talk of the special angles. Right, here we deal first of all 30 degrees and 60 degrees. Right. All right, for us to find the trigonometric ratios of 30 degrees and 60 degrees, what is required is a triangle. Usually trigonometry requires you to have a triangle. And this triangle that you have, it should be a triangle which is equilateral. We'll be talking of the equilateral triangle, but the triangle should have sides which are 2 unit distance each. Right, so here we are going to consider a triangle that is equilateral. Triangle with 2 unit length, and again should also have a particular height of some kind. Right, so here I will draw a triangle which is equilateral. We know equilateral triangle is a triangle which has got all 3 sides equal in length. So here we are. Right. Why have I chosen an equilateral triangle, not any other triangle? Equilateral triangle is a triangle that in its nature, if you talk of the properties of which equilateral triangle has the angles which are 60 degrees as such. So within it, we can also bring some other properties that will be able to give us the angle of what? 30 degrees. So the whole essence about the trigonometric ratios of the 30, 60 degrees are all coming from the what? Equilateral triangle, because of the properties that it has. So here I have my equilateral triangle such, you may be able to depict that say all the angles inside here must be what? 60 degrees. So this is 60, this one is 60, this also is what? 60 degrees. While all sides here are equal like this. Right. So if we are considering 2 unit length as such, we should be able to expect the distance from here up to that should be 2. Distance from here up to that is also 2. And then from here up to that is also what? 2 as such. Now, for us to have a 30 degrees in the same triangle, what we need to do here, we need at least to construct a perpendicular height that has to attach one of the vertices of that triangle and then meet one side at 90 degrees. So in this case, it means I can construct a perpendicular distance from this vertex here. Let me describe this vertex as A, this one as B, this one as C. So my triangle, my height will be a line from A going down to BC, meeting BC at this point here, where I can describe that point as point, maybe whatever point, let us have it as D. So this is just a height, a D. So in short, let's consider a equilateral triangle with sides 2 unit length with a height AD as such. So once we have got the height AD, by the properties of the equilateral triangle, we should be in the position to expect that this line here has to bisect this angle up there. So if the whole of this angle is 60 degrees, we expect that the angle in the 2 triangles here, this angle here must be 30 degrees. This one also should also do what? 30 degrees. As such, it means we are able to come up with a triangle which has got these angles here indicated. So let us consider this situation, what we have here. Right, so as much as we know that if we construct a height like this one here, mark that it bisects the angle up there, which is 60 degrees, we should also be in the position if we are able to prove that the 2 triangles which have been formed the moment we have constructed this height, triangle ADB and triangle ADC, these triangles must be congruent to each other. You can use must be congruent to each other. You can use any of the congruency tests such. So if the 2 triangles are congruent, then for sure we have to expect that these 2 sides here must be corresponding to each other, meaning to say that side BD should be equal to side what? DC. So if BD is equal to DC, then definitely what do we expect about the length, the size of the length from B to D and also D to C? If the whole of this side here BC is 2 centimeters, then definitely we have to expect that from here up that should be 1 unit, and then from here up that is also what? 1 unit as such. So this is what we need, as much as we are going to produce something about the trigonometric ratios of the 30 and 60 degrees. So please master, because it's not good to just memorize the values of the tan, cosine of 30 and 60 degrees as such. So this is what we do. Right, so always remember, if you talk over 30 and 60 degrees, the first thing that we need to consider is an issue about how do I do it. So please consider a triangle which is equilateral with 60 degrees angles, and the sides should be 2 units. Then have a height like this one. We should be able to bisect the side BC into 1 unit and 1 unit, and the angle up there, which is A, should be 30 degrees and 30 degrees. Right, so now, once we have done this, then definitely we have the situation where we have got 2 right angles there. As such, the principles about the trig will be able to work very well. Because if you remember earlier what I said, we just like trigonometry usually works in the triangles. But for trig one, we're talking of right angle triangles, so we have it there. So now, let's first of all come now into triangle. Let's say let us take one triangle out of the 2, which are just the same. If we can consider triangle, that is triangle ADB. Considering triangle ADB, that's in triangle ADB, you'll be able to see that this triangle, if I can draw here in a sketch way, depicting from the entire shape, it looks something like this. This is A, this is B, and this one is vertex D. D is the vertex which contains the right angle, that's 90 degrees, because this line is a perpendicular height. And you'll be able to see that the side AB is equal to 2 units. And the distance, that's a BD from what we have just discussed here, you'll be able to consider this one as 1 unit, right? And this angle here is 60 degrees. From the same, you'll be able to see that this angle here is 30 degrees. So I target those 2 angles, 30 and 60. So now, since we talk of the trig, talk of sine, cos, and tan, it means we need to have the values for all the sides of that triangle. So we have this side here as 2, this one as 1, but we don't have this side here. So what do we do? Let us find the value of this side, so that when we're working out the trigonometric ratios of 30 and 60 degrees by what we have been doing for those ratios we introduced earlier, we should be in the position to find the value of AD here and can be used accordingly. So you can really come up with means and ways of coming up with AD. I know where you are. Mark that this is right angle triangle. For us to work out the value of AD, I think it will not be a problem. Considering what we did in JCE, you'll be able to tell me that to find the value of AD, we can use Pythagorean theorem. So now, let us use that knowledge to work out the value of AD. So here we are, we say by Pythagorean theorem. Let us work out the value of AD. Right, so this is the way we go. Right, so for AD there, it means you need to introduce the Pythagorean statement that will be able to give us the value of AD. So by Pythagorean statement there, we always consider first of the talk of the hypotenuse side, which has to be related with the remaining 2 sides. So we know that for sure, if we talk of the square on the hypotenuse side, which is side BC here, it's just equal to the sum of the squares of the other 2 sides. So in this case, the squares of the other 2 sides, we talk of AD squared. If you add with BD squared, that one will give you what? Talk of what? AB squared. So this is the statement of Pythagoras. So now if we are there now to substitute for the values of those mentioned sides, you'll be able to realize that if you talk of AD, AD here is given, is not given, and that's the target, we like to find that side. So we leave it like that, then we'll just write here AD squared, then plus, you talk of BD, BD is 1, so here we're going to write 1 squared. And then we have got AB squared, which in this case for AB is 2, so we're going to write substitute for 2, and then we square like this. After that, let's try to simplify. You'll be able to see that if we simplify this, we still have the AD as such, and then here 1 squared give us 1, and 2 squared give us a 4. So if I arrange like terms together, we'll have our AD squared being into 4, 1 comes here to be negative 1, and then that you talk of the AD squared is equal to a 3. Right, so once we have done that, we can now find the value of AD. So to find the value of AD, we need to get rid of the power which is here, which is a 2. So to get rid of the power 2, we have to take the square root on both sides. Right, so if I take the square root of AD squared, I'll have AD, and the same measure has to be applied to the other side in order not to violate the rules of the equation. It means I also take the square root of this, and this will remain like that, like this. That is the square root of 3. So in this case, if we are not to proceed our way, we may prefer to leave the value of AD in sad form as such. Like, you don't have to go further into a decimal fraction because we are not targeting at that. Then it's more like using a calculator. Right, so our AD in the equilateral triangle, if we have brought all those issues, we have to consider the AD as the root of a 3. Right, so please, my dear students and everybody who's out there, look at what we're doing here and master them out. That each time we talk about 30 degrees, 60 degrees, at least the principles of what we have done here has to be considered. So I don't think if you can forget of what we have discussed here. So now, what do we have here now? You'll be in the position to pick it out that say, now if I would need now to work out everything about the 30 and 60 degrees, you find that it's very easy. You have got the values attached. So if you talk of the trig ratios of the 30 degrees and 60 degrees, we can just use that triangle up there. So what we have now here, it means we are able, they are now going to fill up the gap like this. Let me now lay this one out. I think you have already taken note of this. Right, so if I'll bring my chart here, it means this is what we are going to get from this analyzation here. So let me come up with my chart, which I brought earlier, right, where I would need to come up with the trigonometric ratio of the first two special angles. Right. Alright, so look at this. Let me just have it that way there. Just a simple activity. So you have to master the activity, not necessarily memorizing the values. That's not all that worth it. If you forget, you find that you may miss the correct solution in the exam. Right. So this is our chart. The 30 degrees and 60 degrees are indicated here. This is our 30, this is our 60. So if I'd like to find the, first of all, sine of 30 degrees, we know for sure sine is found when we divide the opposite divided by what? Hypotenuse. So you talk of the opposite over hypotenuse. So if you come to this triangle here, you find that the opposite side for the talk of the 30 degrees is 1. And if you talk of the hypotenuse side for this triangle is 2. So which means if you talk of the sine of 30 degrees, that one should be equal to 1 over 2. So here we're going to indicate it that this time we talk of the 1 over 2, which is just like a half. The same if we talk of the sine of 60 degrees. Then now the sine of 60 degrees should be opposite side to 60 degrees is root 3, and the hypotenuse side remains the 2. So it should be root 3 over a 2. So here I'll indicate it that's a root of a 3 over a 2. Right, so you need to be able to know how to produce the root of a 3 over 2, and then 1 over 2 at the sine of 30 degrees, by the activities that we have done here. Then now if we go to cosine of 30 degrees, cos we know of an angle is found when we divide that talk of the adjacent side by the hypotenuse side. So if this is the 30 degrees, this is adjacent side to 30 degrees, and this hypotenuse side, so we have to get it as a root 3 over a 2. So cos of 30 degrees is equal to root of a 3 over a 2. And that cosine of 60 degrees, adjacent side is 1. That hyperbolic side is 2. So in that case, it gives you what? You talk of a half. So which means if you talk of sine of 30 degrees, that is the same as cosine of what? 60 degrees. Cos 60 degrees is equal to what? Sine 30 degrees. And then going further, we talk of now tan. Tan of 30 degrees. You can still refer from the same word triangle that we have up there. Tan 30. 30 is here. Tan is found when we divide talk of the opposite side by the adjacent side. So what we have here, we talk of the opposite side to 30 degrees is 1, and the adjacent side is the AD, which is root over 3. So which means in this case, we talk of the tan of 30 degrees, that is 1 over root over a 3, like that. Then lastly, let's talk of the tan of what? 60 degrees. Tan of 60 degrees in this case will be equal to what? Talk of the, this is the 60 degrees, adjacent side is this one, and the talk of the opposite side is root over 3, where we know that say tan is worked on when we divide that's the opposite by adjacent side. So here it means root over 3 divided by 1, which is as good as just writing what? Root over 3. So here, tan here, just write a root of a 3. You can still indicate over a 1, but it's just the same as such. Right, so this is what we have in the first category of the special angles. So every time we are asked maybe to work out something about the trigonometry, you may be asked sometimes to find the value of a certain side, and they'll ask you to leave the answer in sad form. So it means in that case, please divert your knowledge from using a calculator, use at least the values in special angles. So if they talk of the tan of 60 degrees, don't use the calculator, just bring this one out, because this is already expressed in sad form. We call talk of the root over 3, things like that. And the moment again those ask you not to use the calculator, it means what they want you to do is using these values that we have here. Right, so please students, master how we have brought this one up. What is more important is the activity, not necessarily mastering this one. It can confuse you sometimes. So the baseline is the equilateral triangle. Easy to know that. 2 unit sides, 2, 2, 2, 2. Come up with the height like that. You see what I say here? Then the height, if you have the height, definitely that height is going to bisect the side and the angle. So here you have one that is 1. And up here is the 30, here 30. And we know that the equilateral triangle has got 60 degrees. So if this is 60, this is 60. It's a simple thing to know. By Pythagoras, you are able to find the value of this one. This becomes as root over 3. So what do you do next? Just master how to pick up those ratios. Get to know which one is the opposite side, which one is the adjacent side, which is the hypotenuse side, to a particular angle, to 30 degrees, to what? 60 degrees. Then you can work out on that one without even memorizing this. But what is there needed? Just master how we bring that one out. Right, so at the moment, thank you very much for having together in the first category. In the next meeting, we are there going to try and work out some problems and how best you can use this one. Some kind of problem that you expect that demands you to use the knowledge that you have here. Right, so let's meet again in the next video and see how we can apply the concepts. Thank you.